right, so now that we have some rules to use for rotations, let's go ahead and see how this looks. The question on the left says, how can we rotate any geometric figure 90 degrees counterclockwise in the coordinate plane? And as we discussed, we're using the term counterclockwise here, but it should be implied that when we are rotating, we always go counterclockwise, and it works the same as the way our quadrants work. So we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4 in our coordinate plane here. And we've been given some points. In fact, it tells us triangle ABC has vertices A, B, and C, and we're looking for a 90-degree counterclockwise process. So the first thing we probably want to do is go ahead and graph the pre-image, and I'm going to do that by just counting. And so there's 2 on the looking at the A coordinate at 2, 7. So 2 on the X, 1, 2, 3, 4, 5, 6, 7 here. And we'll put a little A there so we can remember he's our pre-image. Then we have B at 6, 5. So there's 6, 7, 6 on the X, 1, 2, 3, 4, 5. There's B, and then we have C at 4, 1, 2, 3, 4, and then 1. All right, and let's go ahead and draw our triangle. And my drawing is not going so pretty on this board, but hopefully yours looks nicer. All right, so the goal now is to determine what the image points are going to be, and we need to use the rules that we were told above. We know the image point is going to end up being a negative y, comma, x based on the original points. So I'm going to put over here on the side, just write the term ORIG to remember what my original points were. And my A was 2, 7, my B was 6, 5, and then the C was 4, 1. So I'm going to need to do some adjustments. It tells me that whatever my X value was is going to live in the Y value when I create the image. So I'm going to go ahead and take all my X's that were here and dump them into the Y section based on the way this rule works. So for the A prime number, we're going to have 2 in the Y, B prime is 6 in Y, and 4 for our Y for C prime. And then what we're going to do to determine our X value, it tells us the rule says it's going to be negative Y. So whatever our Y value was becomes a negative, and it lives in the X location. So I'm just going to input that information here. All right, so I have determined the new points using the rule, and now I'm going to plot those points and kind of see how they look. So A prime is at negative 7, 2, so that's 1, 2, 3, 4, 5, 6, 7, negative X, and then 2 here on the Y. So we're going to put in A prime to show that that's the point that we just created for our image. And then for B prime, we're going 5 to the left, so 1, 2, 3, 4, 5, and then 6 up. 1, 2, 3, 4, 5, 6 is here, and that would be my B prime, so I'm going to put a B prime there. And then C prime is at negative 1, 4, so I'm going to go negative 1 here on the X, and then 1, 2, 3, 4. And now I'm going to put a C prime here, and I'm going to connect my dots to create a triangle, and hopefully this one will be prettier. All right. So the deal is when you're in the coordinate plane and you're rotating a figure, you can see that the A essentially shifted 1 quadrant over. Okay, so when we're going 90 degrees, no matter where we start, we're not always going to start in the first quadrant. The original or the pre-image might end up somewhere in the 3rd or the 4th or wherever they decide to put it. But to create the image, if we're doing 90 degrees, from the first quadrant, we're going to just move over 1 quadrant, and you can kind of see how he has turned and has the A has gone over here, our B, let me make that prettier, the B has moved from here around to this point, and then C as well has moved around to this point. Again, this is an isometric transformation, so the actual size of the shape has not adjusted whatsoever. It's just moved, and that's what we're going for when we talk about isometrics. The rotation is isometric. What if the question asks to rotate 270 degrees clockwise in this case? So they're actually giving us the clockwise. Again, if it's not stated in terms of the direction, it's implied counterclockwise. And I'm just going to put CCW. If they tell us it's clockwise, then at that point we know we're no longer moving this way. We're going to be going as the clock goes around this way. So what if the question asks to rotate clockwise 270 degrees? In the situation we have here, we would be moving essentially 3 quadrants clockwise. So from the first quadrant, we would be moving 90 degrees plus another 180 degrees, and then finally end up at 270 degrees. You can kind of think of it like 90 degrees as you shift around your origin, which remember he is at 0, 0. So if they ask us to rotate clockwise 270 degrees, it's the same exact thing as counterclockwise 90 degrees. So the actual rule would stay the same. All right, so let's go to the back of the page. Oh, went too far. All right. So how can we rotate any geometric figure 270 degrees counterclockwise in a coordinate plane? We just talked about going clockwise. Now we're going counterclockwise. So thankfully we have a rule that we're going to use. And remember from the front of the sheet, the rule for a 270 degree rotation in a coordinate plane turns into what was originally x comma y turns into the new point or the image point of y negative x. So I'm going to go ahead and get you started. Let's go ahead and write the original information here. We had a G, again we have a triangle GHI with the vertices here, here, and here at a 270 degree counterclockwise rotation. So I'm going to do a 0, -2 is the original. Our H was a 7, -6. And then the I value we had was a 3, -8. And when you're having to do this many rotations, and you'll see this in your homework, it's a really good idea to write all of this information down. If you try to just do this by memory or looking back up here and then trying to get your right information for your rule, you're really going to get confused. I know I always do, so I do try to write it all out. So again, back to our rule, we had a y and a -x. And again, so what happened, what we're going to essentially do is take what the original y value was, the -2, the -6, and the -8, and dump those into the y location. Okay, so I'm going to do that first. And then we're going to take what originally was the x, we're going to change the sign and dump it into the y value. So if we change the sign to 0, we're not doing anything to it. We're just leaving it 0. Changing the sign of 7 turns into a -7, and then we've got a -3. So these are our pre-image points, and then here are our image points. And go ahead and pause the video. I want you to plot these points. I want you to draw the original image, and then plot the points for the the pre-image, and then plot the points for the image, and hopefully your picture is going to look just like mine after you come back. So pause the video and do that and come back. Okay, so you should have gotten these two pictures on your coordinate plane. Remember the G, the H, and the I, those were our original points or our pre-image, and then our G prime, I prime, and H prime represent the new points for the image based on the rotation of 270 degrees. So in this case, getting back to our quadrants, we've got 1, 2, 3, and then 4. And this original or the pre-image actually started in the 4th quadrant. Remember, we're going 270 degrees counterclockwise. We're doing a 270 degree rotation. So he has moved this far, or from the 4th quadrant all the way over to the 3rd quadrant. The 90 degree rotation would have put him here in the 1st quadrant. A 180 degree rotation would have him over here in the 2nd quadrant. And then because we are in a 270 degree rotation, it puts him right here in the 3rd quadrant. All right, so you can kind of think through that as you're looking through your homework examples. I think there's about 3 of these you're going to walk through. All right, so next question. How can we determine images of rotation using what we know about tessellation. So we've got a hexagon here, JKLMNO. We're trying to do some rotation information of original images after certain rotations. We have information, we have enough information to do what we need to do, but let's go ahead and break this guy. Oh, I'm not going to do a good job with my pictures here. I'm going to use a line tool. So I'm going to break this guy into multiple segments. When we were doing those, break your polygons into random triangles, a lot of you guys kind of created sort of a wagon wheel or a pinwheel kind of look. And really, when we're talking about rotations, this is the best way to represent the way we're going to rotate this information. Remember our tessellation, when we have a point in the middle of numerous angles, we've got a 360-degree rotation that is occurring. And that concept of tessellations actually applies very well here in our rotations world. We have 6 identical angles. We know that because, frankly, this is actually a regular hexagon, and that's kind of important. And so we can determine just what degrees each of these are. 360 total, I've got 6 separate angles. It would be 360 divided by 6 because we're sharing those, and we turn into 60 degrees per angle. Okay, so we'll just put a couple of 60 degrees inside these so we know what we have going on, because that's going to be important. Okay, so remember, I'm not giving you specific directions here, and we know that the implied rotation is always going to be rotation counterclockwise. So we're going to start at point J. We want to consider this a point. It would be as if it's in a coordinate plane, and we're going to rotate 120 degrees about T. Now T was our point in the middle. Okay, so he was kind of the vertex of that tessellation that told us how to determine all these angles. We need to go 120 degrees counterclockwise because that's the implied direction. And in order to do that, the way we're going to do that is look at the angles that are created in the middle. To go from J to O, we had to travel 60 total degrees. Okay, even though our circle is down here, technically speaking, we still only went 60 degrees total. So this is a 60-degree rotation. That's not quite enough. Remember, I need 120, so then I need to go one more point over because I need 120 total. Okay, so this turns into 120 by the time I've gone 2 spots. And what that tells me is that the image I have created, or what I found, is at N. Point N is the image of J after a 120-degree rotation, because again, I'm using this as my tool to determine just how far I'm going. Okay, it's the angle of how far that rotation is taking me. All right, let's look at the second one, and then I'll have you guys finish these out. Okay, now we've got the image of M after a 300-degree rotation about T. All right, I'm going to erase some of this, whoops, because I want to make sure you guys understand what direction or how we're rolling with this. So starting with M, this time they give me the direction of clockwise. So instead of going this direction around, I'm going to be going instead of going this direction, I'm going to be going this direction the way the clock goes. So I'm going to start at M, and I'm looking for 300 total degrees. So I'm going to just kind of count it off to go from M to N. That gets me 60 degrees. To go from N to O, that gets me to 120 degrees. I'm going to keep going because I need to get to 300. O to J gets me to 180. And then J to K gets me to 240. And then finally, L or K to L gets me to 300 total degrees, because 60 plus 60 plus 60 plus 60 plus 60 is equal to 300, and that's just how far I had to travel. You can think of it in increments. In this case, 60 times 5 is getting us to 300. However your mind likes to take you as we walk around this hexagon. So our image of M after a 300-degree clockwise rotation about T is going to be point L. All right, so you have 3 more I want you to work through. If you could go ahead and pause the video and then take a look and see how you did once you finish. All right, and you should have gotten the fact that J was the image of K after 60 degrees, M was the image of L after 300, and then K was O after 120 clockwise. If you didn't get those, raise your hand and we'll give you some help.